Projected 30% job creation in STEM fields due to Mars project initiatives by 2030. Executive Summary. The ongoing initiatives surrounding Mars projects are set to have a profound impact on the workforce landscape in the United States, particularly within the STEM science, technology, engineering, and mathematics fields. By 2030, these initiatives are projected to create a 30% increase in STEM job opportunities, reshaping the current employment landscape to meet the demands of a technologically advanced future. This report highlights the trends, projections, and implications of this job growth, drawing from various authoritative sources. Current landscape of STEM employment. As of 2021, approximately 24% of the U.S. workforce, equating to about 36.8 million workers, were employed in STEM occupations. This sector has experienced a steady increase in recent years, and projections from the Bureau of Labor Statistics (BLS) indicate that STEM jobs will grow at a rate of 7% from 2022 to 2032. In contrast, non-STEM jobs are expected to grow at a mere 2%. Key roles such as data scientists and information security analysts are anticipated to see growth rates of 35 to 45%, emphasizing the higher demand for specialized skills in these areas. The National Science Foundation (NSF) also notes that over half of the current STEM workforce does not hold a bachelor's degree, illustrating the diverse pathways into these roles, including skilled technical occupations. The trend indicates a shift toward a more inclusive workforce, opening doors for individuals with various educational backgrounds. Global context of job creation. The World Economic Forum's Future of Jobs Report 2025 underscores the global employment landscape, projecting the creation of 78 million net new jobs worldwide by 2030, despite the displacement of 92 million jobs due to technological advancements. The report emphasizes the importance of reskilling and upskilling for the workforce, as nearly 40% of skills required are expected to change significantly. The focus on AI, renewable energy, and advanced technologies will create not only traditional STEM positions but also new roles in emerging sectors. Projected growth and skill requirements. The anticipated growth in STEM jobs due to Mars initiatives is driven by several factors. 1. Technological advancements. Ongoing research and development for Mars exploration require a highly skilled workforce proficient in robotics, data analysis, and engineering. 2. Investment in education and training. Collaboration among businesses, government, and educational institutions is essential to prepare the workforce. Programs aimed at reskilling and upskilling will be critical to meet the evolving demands of the job market. 3. Diverse career pathways. The Mars initiatives will not only bolster high-skilled positions but also create opportunities in middle-skill roles, which are crucial for supporting the infrastructure of space exploration. The BLS has identified several high-growth STEM occupations, including data scientists, projected to grow by 36% from 2021 to 2031 with a median annual pay of $100,910. Information security analysts, expected to grow by 35% with a median pay of $102,600. Statisticians and data analysts, anticipated growth of 33% and a median pay of $95,570. These roles will require a combination of advanced degrees and practical experience, emphasizing the need for educational institutions to adapt their curricula to prepare students for these high-demand jobs. Collaboration for future workforce development. The transformation of the workforce landscape necessitates a collaborative approach among various stakeholders. The NSF emphasizes the importance of demographic diversity within the STEM workforce, advocating for increased representation of underrepresented groups. The World Economic Forum highlights the urgency of addressing skills gaps through partnerships among businesses, educational institutions, and government agencies. By fostering a culture of continuous learning and development, stakeholders can ensure that workers are equipped with the necessary skills to thrive in future job markets. This includes not only technical skills but also essential human skills such as adaptability, critical thinking, and problem solving. Conclusion. The projected 30% increase in STEM job creation due to Mars project initiatives by 2030 is a significant development that will reshape the workforce landscape in the United States. As technological advancements continue to drive demand for specialized skills, the importance of reskilling and upskilling cannot be overstated. Collaborative efforts among various sectors will be essential to bridge the skills gap and prepare the workforce for the evolving job market. In summary, the Mars initiatives represent a transformative opportunity for the STEM workforce, underscoring the importance of education diversity and adaptability in meeting future challenges. As we look towards 2030, the focus on building a resilient and skilled workforce will be crucial to harnessing the potential of these groundbreaking projects. The projected 30% increase in STEM jobs in the U.S. due to Mars project initiatives by 2030 presents some counterintuitive insights. Here are key points that illustrate these paradoxes. 1. Higher job growth without higher education. While the traditional view holds that STEM jobs require a bachelor's degree, over half of the current STEM workforce does not possess one. This trend may continue, suggesting that job creation in STEM fields could largely benefit those without formal higher education, challenging the assumption that advanced education is a prerequisite for success in these sectors. 2. Rise of middle-skill jobs. The focus on high-tech roles often overlooks the growing demand for middle-skill jobs in STEM. As new technologies emerge, there will be a significant number of positions that do not require a 4-year degree but still provide substantial opportunities and competitive wages, contradicting the stereotype that STEM is solely for highly educated professionals. 3. Job creation amid displacement. While the Mars project initiatives are expected to create new STEM jobs, the World Economic Forum reports that 92 million jobs will also be displaced by 2030. This duality suggests that while there is growth in certain areas, many existing roles may vanish, leading to a more competitive job market where workers need to rapidly adapt and reskill. Challenging the notion that growth equates to stability. For fastest growth and unexpected roles, the jobs projected to grow the fastest include not only traditional STEM roles like data scientists but also positions in sectors like renewable energy and care professions. This diversification defies the expectation that STEM job growth would be confined to high-tech fields, demonstrating a broader impact across various industries. 5. Human skills valued alongside technical skills. Despite the emphasis on technological skills such as AI and big data, the report highlights a simultaneous need for human skills, including creativity and collaboration. This suggests that the future job market will prioritize a hybrid skill set, contradicting the belief that technical expertise is all that is necessary for success in STEM. 6. Economic pressures affecting job markets. The anticipated job creation is influenced not only by technological advancements but also by economic pressures such as rising costs of living and inflation. This reality reveals that job growth may not be solely driven by innovation and demand for tech skills but also by external economic factors that shape workforce needs in unexpected ways. 7. Geopolitical tensions driving job creation. The report indicates that geopolitical tensions are reshaping labor markets, compelling companies to adapt their strategies through offshoring and reshoring. This geopolitical aspect complicates the narrative that technological advancements are the sole drivers of job creation in STEM, as external political dynamics also play a pivotal role. These counterintuitive insights reflect a rapidly evolving workforce landscape where traditional assumptions about education, job roles, and the drivers of employment growth are being challenged. The future of work in STEM may require a re-evaluation of how skills are developed and valued in light of these complex dynamics. The report on the projected impact of Mars project initiatives on job creation in STEM fields across the U.S. is noteworthy for several reasons. While the headline figure of a 30% increase in STEM jobs by 2030 is indeed striking, there are critical elements within the report that many may overlook which carry significant implications for the workforce landscape. 1. Demographic insights into the current STEM workforce. One of the most important yet often overlooked aspects is the demographic distribution and educational attainment of the current STEM workforce. According to the National Science Foundation, Over half 52% of STEM workers do not hold a bachelor's degree. This statistic challenges the common perception that STEM roles are predominantly filled by highly educated individuals. Understanding that a substantial portion of the workforce is comprised of skilled technical workers (STW) who do not have a 4-year degree is crucial. Significance: this insight points to the potential for expanding access to STEM careers through alternative education pathways such as vocational training or community college programs. As the demand for STEM jobs grows, initiatives that support these pathways could play a pivotal role in shaping a more inclusive workforce. 2. Skills gap and upskilling needs. The report emphasizes a significant skills gap, with nearly 40% of skills required in the workforce anticipated to change by 2030. This is corroborated by the World Economic Forum's findings, which indicate that 63% of employers cite the skills gap as a key barrier to business transformation. Significance: the urgency for reskilling and upskilling cannot be overstated. As technological advancements accelerate, workers who are unable to adapt may find themselves at risk of displacement. This highlights the need for collaborative efforts among businesses, educational institutions, and governments to create training programs that align with future job requirements. The focus should not only be on technical skills but also on human skills like cognitive flexibility and collaboration, which are becoming increasingly important. 3. Regional disparities in STEM employment. Another critical element that may be overlooked is the geographic distribution of STEM jobs. The report does not delve deeply into how different regions may experience varying impacts from the Mars Project initiatives. Some areas may see significant job creation while others may lag due to a lack of infrastructure, educational resources, or industry presence. Significance: understanding regional disparities is essential for targeted policymaking and investment. Initiatives may need to be tailored to specific geographic areas to ensure equitable job creation and workforce development. Additionally, stakeholders must consider how to attract STEM opportunities to underrepresented regions to foster economic growth and sustainability. 4. The role of emerging technologies. The report highlights the anticipated growth in specific STEM roles driven by emerging technologies such as AI, renewable energy, and data science. For instance, data scientists and information security analysts are projected to grow by 35 to 45% over the next decade. Significance: this underscores the necessity for educational institutions to adapt their curricula to prepare students for these high-demand roles. Additionally, businesses must invest in continuous training to ensure their employees can transition into these emerging fields. The focus on emerging technologies also suggests that traditional STEM roles may evolve, requiring a more interdisciplinary approach to education and training. 5. Impact of global trends on local job markets. The report touches on broader global trends impacting job creation, such as technological advancements and demographic shifts, but it does not fully explore how these trends will affect local job markets. For example, while the report projects a net increase of 78 million jobs globally by 2030, it also notes that 92 million jobs may be displaced. Significance: the juxtaposition of job creation and displacement highlights the complexity of the labor market. Policymakers and businesses must anticipate these changes and implement strategies for workforce transition. This includes support for workers in declining industries and ensuring that new job opportunities are accessible to those who may be displaced. 6. Inclusion and equity in STEM education. The discussion on who comprises the STEM workforce reveals a critical area for improvement: the need for greater inclusion and diversity within STEM fields. The current workforce does not adequately reflect the demographic diversity of the U.S., which could hinder innovation and creativity in problem solving. Significance: fostering diversity within STEM roles is not just a matter of equity, it is also essential for enhancing the innovative capacity of the workforce. Programs aimed at encouraging underrepresented groups to pursue STEM education and careers can lead to a more vibrant and effective workforce, ultimately benefiting the economy and society as a whole. 7. The economic implications of STEM job growth. The projected increase in STEM jobs comes with substantial economic implications. The median annual wage for STEM occupations is significantly higher than for non-STEM jobs, which can lead to greater economic mobility for workers who enter these fields. Significance: this wage disparity emphasizes the importance of STEM education and training as pathways to economic stability and growth. Efforts to expand access to STEM training can have a profound impact not only on individual livelihoods but also on the overall economy, as a more skilled workforce can contribute to increased productivity and innovation. 8. Importance of collaboration across sectors. The necessity for collaboration among businesses, governments, and educational institutions is a recurring theme throughout the report. While many stakeholders may recognize this need, the specifics of how to implement successful collaborations often remain vague. Significance: effective collaboration can lead to the development of tailored educational programs, internships, and apprenticeships that are aligned with industry needs. By fostering partnerships that bridge the gap between education and employment, stakeholders can ensure that the workforce is equipped with the skills necessary to thrive in the evolving job market. Conclusion: the projected 30% increase in STEM jobs due to Mars project initiatives by 2030 is just the tip of the iceberg. The nuances within the report, such as demographic insights, skills gaps, regional disparities, and the need for collaboration, are critical elements that hold the key to shaping a future-ready workforce. Addressing these overlooked aspects can lead to more informed decision-making and proactive strategies that not only prepare individuals for emerging opportunities but also enhance the overall competitiveness and resilience of the U.S. workforce in a rapidly changing global landscape. 1. Projected job growth in STEM fields. The Mars project initiatives are expected to amplify job creation in STEM fields, projecting a 30% increase in STEM employment across the U.S. by 2030. This growth is significantly higher than the national average for non-STEM jobs, which are projected to grow at just 2% over the same period. The National Science Foundation indicates that the number of STEM jobs will grow at a rate of 7% from 2022 to 2032, highlighting a robust demand for technical skills in various sectors, including advanced technology, data sciences, and information security. 2. Skills gap and need for reskilling. A critical point emerging from the discussion is the urgent need for reskilling and upskilling the current workforce to meet the evolving demands of the job market. The World Economic Forum emphasizes that nearly 40% of skills required in the workforce are anticipated to change by 2030. To bridge the skills gap, collaboration among businesses, governments, and educational institutions is essential. This collective effort is necessary to prepare a workforce equipped with the technological skills and human capabilities needed for future job roles, particularly in AI, data analytics, and renewable energy sectors. 3. Demographic distribution and educational attainment. The demographic dynamics within the STEM workforce present an intriguing landscape. Notably, over half of the STEM workforce does not hold a bachelor's degree, indicating that skilled technical positions can offer substantial employment opportunities without requiring a 4-year degree. This trend underscores the importance of diverse educational pathways, including vocational training and associate degree programs, to fill the increasing number of STEM positions. The National Science Foundation highlights that as of 2021, 24% of the U.S. workforce was employed in STEM occupations, a figure that is expected to grow, reflecting a shift in workforce demographics and educational attainment in high-demand fields. For economic impact and workforce resilience, the economic implications of the projected job growth in STEM fields extend beyond individual employment opportunities. As STEM occupations typically offer higher median wages, around $95,420 compared to non-STEM roles approximately $40,120, this shift can contribute significantly to economic growth and competitiveness. Additionally, the World Economic Forum projects a net increase of 78 million jobs globally by 2030. Emphasizing the transformative potential of technological advancements and the need for a resilient workforce capable of adapting to rapid changes in the labor market. The focus on both technological and human skills will be crucial in fostering a workforce that can thrive in the face of emerging challenges and opportunities. 1. The Apollo Program 1960s to 1970s. The United States Apollo program aimed to land humans on the moon and bring them safely back to Earth. It was initiated by President John F. Kennedy in 1961 and culminated in the Apollo 11 mission in 1969. The program not only achieved its goal of lunar exploration but also resulted in significant job creation in STEM fields. Thousands of engineers, scientists, and technicians were employed, leading to advancements in materials science, computer technology, and telecommunications. The skills and technologies developed during this era laid the groundwork for many modern industries and significantly reshaped the U.S. workforce. 2. The Manhattan Project 1942 to 1946. During World War II, the U.S. government initiated the Manhattan Project to develop the atomic bomb. This massive research and development project brought together some of the brightest minds in physics, chemistry, and engineering, creating thousands of jobs in STEM fields. The project not only resulted in the atomic bomb but also advanced various scientific fields, leading to the establishment of institutions like Los Alamos National Laboratory. The long-term impact on the workforce included a significant increase in demand for scientists and engineers, influencing post-war education and job markets. 3. The Internet and dot-com boom 1990s. The rise of the Internet in the late 20th century transformed economies and job markets globally. The dot-com boom, particularly during the late 1990s, saw a rapid increase in technology jobs, including web developers, software engineers, and network administrators. Companies like Amazon, Google, and eBay emerged, creating millions of jobs in STEM fields. This shift not only shaped the workforce landscape by driving demand for technical skills but also led to a cultural shift towards digital literacy and technology reliance, influencing education and professional training programs significantly. The projected impact of Mars Project initiatives on job creation in STEM, science, technology, engineering, and mathematics fields across the U.S. is poised for transformative growth, with estimates indicating a 30% increase in STEM jobs by 2030. This surge is anticipated to reshape the workforce landscape, driven by technological advancements and the urgent need for specialized skill sets. Current landscape and future projections. As of 2021, STEM occupations accounted for approximately 24% of the U.S. workforce, translating to about 36.8 million workers. This sector has experienced a significant upward trajectory over the past decade, with projections from the Bureau of Labor Statistics (BLS) suggesting a robust growth rate of 7% for STEM jobs from 2022 to 2032, outpacing the mere 2% growth expected for non-STEM roles. Specific STEM roles are projected to expand even more dramatically. For instance, data scientists and information security analysts are expected to see job growth between 35% and 45% over the next decade. This trend underscores not only the demand for these positions but also the increasing necessity for technical skills in a rapidly evolving job market. Driving forces behind job creation. The anticipated job creation is largely attributed to several key factors. 1. Technological advancements. Innovations in artificial intelligence, AI, data analytics, renewable energy, and advanced manufacturing are projected to create new job categories while simultaneously enhancing existing roles. 2. Mars Project initiatives. The push towards Mars exploration is expected to catalyze job creation in areas such as aerospace engineering, robotics, and environmental science. This ambitious endeavor will require a highly skilled workforce capable of addressing unprecedented challenges. 3. Reskilling and upskilling. A critical aspect of this transformation will be the need for reskilling and upskilling the current workforce. With nearly 40% of skills required in the workforce expected to change by 2030, collaborative efforts among businesses, educational institutions, and government bodies will be essential to prepare workers for the future. Employment trends and skills gap. The World Economic Forum's Future of Jobs report highlights that while 170 million new jobs are expected to be created globally by 2030, 92 million jobs may be displaced, resulting in a net increase of 78 million jobs. This shifting landscape presents both opportunities and risks, emphasizing the importance of addressing the skills gap. Approximately 63% of employers identify skills shortages as a significant barrier to their operations. The fastest growing skill sets will include both technical skills, especially in AI, big data, and cybersecurity, and essential human skills such as communication, creativity, and critical thinking. The convergence of these skills will be crucial for navigating the complexities of the future workforce. Sector-specific growth. 1. Technology sector. The demand for data scientists, software developers, and cybersecurity analysts is expected to soar. For example, data scientists alone are projected to grow by 36% from 2021 to 2031, reflecting the increasing reliance on data-driven decision-making. 2. Healthcare and education. With demographic shifts leading to an aging population, the healthcare sector is set to experience significant growth. Roles such as nursing professionals and secondary school teachers are projected to expand substantially, driven by both demand and necessity. 3. Green jobs. The transition towards renewable energy and sustainable practices will create new opportunities in environmental engineering and related fields. The demand for professionals skilled in sustainable technologies will likely increase as the world focuses on combating climate change. Conclusion. The Mars Project initiatives and broader technological advancements are expected to catalyze a substantial increase in STEM job opportunities, with a projected 30% growth in these fields by 2030. This evolution will redefine the workforce landscape, necessitating ongoing education and training to bridge the skills gap. As industries adapt to new technologies and methodologies, collaborative efforts will be essential to cultivate a skilled workforce prepared for the challenges and opportunities of the future. In summary, the future outlook for STEM jobs in the U.S. is bright, with substantial growth anticipated across various sectors. The key will be to ensure that workers are equipped with the necessary skills to thrive in this rapidly changing environment, fostering a resilient and adaptable workforce for the challenges ahead.